Hello everyone. So today we will have test 7 discussion. So last time we had test 6 discussion. This is test 7. So test 7 is also dealing with physical anthropology. In test 6 we discussed physical anthropology first topics. Here we will discuss second set of topics. This will essentially be from 9.5 to 9.8 and then 10, 11, 12. So these chapters in the syllabus are covered in this test, right? So we will look into the first question. First question is adolescent growth spurt. Very simple question. In fact, I picked this question because this is a previous year question as well. So what do we mean by adolescent growth spurt? So in this question, it's very simple. You have to first begin by explaining what is, one moment. Yeah, you can begin by defining adolescent growth spurt. First, define it. So what is the definition for adolescent growth spurt? It is fast and intensive increase in the rate of growth in height. The rate of growth in height and weight that occurs during the adolescent stage of life. That occurs during the adolescent stage of life. First, define this and then tell roughly what age period you have this. It happens between 12 to 18 years. In that age, you see adolescent growth spurt, and then discuss the aspects of this growth spurt. What are the different aspects of this? How body size, what are the changes that happen in adolescence? So discuss about how you have body size, especially height and weight. What are the changes? And then during adolescent growth spurt, you also have sexual changes or reproductive development. Discuss this. And another angle that you can add to this are the boys versus girls difference. How in boys and girls there is slight difference in adolescent growth spurt. For example, adolescent growth spurt begins slightly earlier in girls than in boys. So I've discussed all that here. So this is a growth spurt which varies from one child to another, and the difference in size in men and women is to a large degree due to difference in timing. So between men and women we have differences in timing and intensity. Before this spurt, boys and girls differ only by about 2% in height and weight, but after this there is variation because it begins earlier in girls. So girls begin to experience rapid development in early stage. In girls it develops around age 12, in boys it develops around age 13 or 14. So that's why girls begin to grow faster and they overtake boys in age, and boys eventually try to catch up. So there is later occurrence in males, and this is the graph that tells you the differences between males and females. So if you look at this graph, yes, purple color is girl, blue color is boy, and here we have height velocity and this shows height. So if you look at this, around age 12, initially girls begin to have greater height. In this period, girls begin to have greater height, boys experience lower height, but after around age 14, spurt begins in boys also, and eventually boys overtake girls, and by the time you reach 18-20, boys are taller than girls. And this here tells us height velocity. So you can draw this curve to show the girl and boy or male and female differences in adolescent growth spurt. This is another curve that shows how the height varies in boys and girls. And yes, so girls are slightly shorter than the typical boy at all ages until adolescence. So generally, if you look at this curve, girls are typically shorter, but except for this short period, girls are typically shorter than boys. And she becomes taller shortly after 11 years because of growth spurt. And at age 14, she is surpassed again in height by the typical boy. And in the same way, girls also weigh a little less than boy at birth and equals him at age 8 and becomes heavier at age 9 or 10 and remains so till about age 14.5. So you can talk about height and weight differences and how this varies. And this curve here is again about height velocity, rate at which height is changing. This is called height velocity curve. So you can draw both height curves. So please draw both the curves, that is this curve and also height velocity curve for adolescent growth spurt. So the velocity curve given here shows this process clearly, and at birth typical boy is growing slightly faster than typical girl, but the velocity becomes equal at about 7 months, and then girl grows faster until age 4. From then till adolescence there is no difference can be seen, and this is general points. Clear? So please go through these other points also, where we have discussed the minute variations between girls and boys when it comes to adolescent growth spurt, both in terms of height and height velocity as well as weight. So the boy begins his spurt and reaches his peak just 2 years later, and the boy's peak is higher than girls. So girls, the spurt starts earlier in girls, but the spurt reaches maximum level in boys. That is the difference. So in girls it starts early but reaches more higher level in boys, and girls are always in advance of boys even at birth. That is how you can answer adolescent growth spurt. So discuss it, discuss the changes, and also discuss the boy versus girl changes along with these curves. The next question is relevance of menarche and menopause. This is a very interesting question because they are asking this question from year on year. I forgot to post the corresponding material for this on the group, so I will just post this on the group as well. So on the Telegram group for the course, I am posting some material. Please, you can go through that for more details and more important content on this topic. So I posted 2 files which give you good amount of content on this topic of the menarche and menopause. So you should first begin this answer by defining what is menarche and defining what is menopause. So what is menarche? Menarche means it marks the beginning of reproductive cycle. Define it. Marks the beginning of reproductive cycle. And age, at what age? Roughly we are seeing it around between 12 to 14, and of late we are seeing a secular trend or a decline in the age of menarche with each generation because of better nutrition and better care. In the file that I shared on the group, you will see in menarche and menopause 1, there is a figure which shows the declining age of menarche over the past 150 years in many European countries. So in many European countries like Sweden, Norway, Denmark, the UK and so on, in 1860s the age of menarche was around 16. The age for example, if you take UK, in 1860 the age of menarche was 16 years, but by 1960 the age of menarche is 13 years. It has come from 16 to 13. So the age at menarche is going through a secular trend of decline that you should discuss. And with this, what is the significance of Menarch? The significance of Menarch is that it marks the beginning of reproduction or reproductive span. This period between menarche and menopause is called as reproductive span. So talk about that. And then menarche also has cultural significance. Menarche also tends to have some kind of cultural significance. Discuss this. You have many puberty rituals celebrating this menarche, and the gap between menarche and menopause is called as reproductive span. And in this span, we can also have something called as theoretical maximum fertility, that is around, for if you have 15 to let's say age 50, theoretical maximum fertility can be around 35. But then nobody reaches 35, and during this menarche and menopause, you also have two periods where there is sterility, temporary sterility. So one is called postpartum sterility. So initially, in the initial days after childbirth, women experience sterility, and also another sterility happens in the early years of puberty. In the early years of puberty also there is sterility, and that is called as adolescent sterility. So discuss about postpartum sterility and adolescent sterility as the things which reduce the fertility. Then define menopause. What is menopause? Menopause means it is the cessation of ovulatory cycles, cessation of menstrual cycles. It marks the end of a woman's reproductive life. This marks the end of a woman's reproductive life. That is menopause. And menopause, typically at what age does menopause occur? It occurs around the age of roughly 50, and year by year it is rising. While age at menarche is decreasing, age at menopause is increasing. And in case of women describe the thing. So when women are born, they are roughly born with 2 million oocytes, or 2 million odd eggs. And by the time they reach menopause, the egg number drops to roughly 400,000 or 4 lakh eggs. So, and then there is one interesting aspect of menopause that you must discuss. Human female is interesting. It is interesting in the sense that in human female, there is a long life after menopause. So if you look at other species like apes and chimpanzees, what happens is that the females do not have much life after they lose their reproductive capacity, or put differently, this event called menopause can be said to be unique to humans. Menopause can be said to be unique to humans in the sense that if you take apes and chimpanzees, the female is capable of reproducing almost until at the end of its lifespan. That's it. So once the female reaches the end of lifespan, then that is the time when it also loses its reproductive capacity. But in human females, what happens? The female experiences something called menopause, that is the reproductive death at 50, but the female can live up to 75 to 80 or something. That means the female has at least 1/3 of her life left even after she has lost reproductive capacity. But if you look at other species like other apes and primates, the female is capable of reproducing only until the end of its lifespan. So why is this so? So many say that in humans also, when the average lifespan was about 50, there was no gap between menopause and total lifespan. There was not much gap. But when human lifespan began to rise because of better health conditions, better nutrition conditions to 75 and so on, then we ended up in a scenario where even after losing the capacity to reproduce, women still have a very long life ahead of them. So this gap is what we are referring to. So why do they have this gap? To explain this, there are two theories. One theory is called the grandmothering hypothesis. One theory is called the grandmothering hypothesis. What does the grandmothering hypothesis tell? This grandmothering hypothesis suggests that uh, why does natural selection favor? Why is natural selection favoring this kind of thing where women have a long life after menopause? So what it is saying is that when women have a long life after menopause, they can become good grandmothers. That is, women can take care of their offspring's children. So as grandmothers and provide for care, and this ability of older women to provide care for the younger ones is good for the family and society. That is the reason, that is the justification given by grandmothering hypothesis for this life after menopause. Second is called mothering hypothesis. The second one is called mothering hypothesis. Mothering hypothesis is telling that no, it is not that we should be good grandmothers. The reason for a long life after menopause is that you can be good mothers. So this theory is suggesting that when mothers have a long life after menopause, that is after 50, they are able to live for a longer period, then mothers are in a position to take good care of their adult children. As a result, the children experience a longer life, and that is probably why natural selection has favored this kind of gap between menopause and death. So that is called as mothering hypothesis. So we have grandmothering hypothesis and mothering hypothesis, two theories, two explanations for why in case of humans alone there is a long life after menopause. That is the discussion, right? So this is how you can answer menarche and menopause. Define them, discuss the ages. In case of menarche, talk about the falling age. In case of menopause, define it and talk about its significance, and also theories which explain the presence of menopause, the significance of menopause in humans, because only humans have menopause-like events. So we have to discuss what is the significance of this so-called menopause. Then we have ABO blood groups. But before going to ABO blood groups, we will discuss a question called epidemiological anthropology. So what is epidemiological anthropology? Epidemiological anthropology is anthropological study of diseases. What do we mean by anthropological study of diseases? I shared a handout on the course, on the test series group, which discusses epidemiological anthropology in great detail. So here I'll just give you a brief overview or a brief structure for what this can mean. So what do anthropological epidemiologists study? What is epidemiology in the first place? It is a science for the study of diseases. Epidemiology means the science for the study and spread of diseases. So what is anthropological study of diseases? Here we are trying to understand what type of diseases were common in prehistoric population, that is among Paleolithic people or Mesolithic or Neolithic, what kind of diseases were common and how did the presence of these diseases affect human evolution. So what is the link between disease and human evolution? Then why are different types of diseases common in some population and not in others? So why do some people experience some diseases whereas others don't experience? So like the relationship between, is there any biological relationship between certain people and the diseases they tend to face? Then for example, why is a classic example of this sickle cell anemia and its relationship with malaria? Why is sickle cell anemia seen more in Africa than other places? Such questions can be answered from this. Then the third issue we are trying to explain is how can an understanding of the evolution of human diseases and how do our understanding of this overall disease pattern, how does that help us in dealing with current disease patterns? So how our general understanding of disease and their evolution helps us to deal with the current patterns of disease. So these are the three issues that epidemiological anthropology studies. So we can talk about these issues and then give some examples of some epidemiological anthropological studies. That's it. Very simple. Next question that we will discuss is blood groups. So ABO blood groups is very simple. So basically talk about the principles behind blood groups. So what is the principle behind blood group? It is nothing but antigen. So blood groups typology is based on the presence of some antigens on cell surfaces. It is based on the presence or absence of some specific antigens on cell surfaces. So this is based on the presence of what is called as cell surface proteins. It is based on the presence or absence of certain cell surface proteins. And generally, ABO blood group is famous because it also has a very easy pattern of inheritance and it tends to follow Mendelian laws of inheritance. So then you should talk about this. So how do we define blood group A, B and AB, AB, A, B, AB and O? So it is based on the presence of antigen. When somebody has A antigen, then we call it group A. When they have B antigen, we call it group B. When they have both the antigens, we call it group AB. And when they have none, we call it O. And then discuss about genotype. Before genotype, phenotype, we should also talk about the dominant recessive relationship. Dominant recessive relationship. What do we mean by dominant recessive relationship? So A is dominant to O. B is dominant to O. A and B are codominant. This is the dominant recessive relationship between these blood groups. A is dominant to O, B is dominant to O, and A, B are codominant. That is the relationship between them. And based on this, you can write the corresponding genotypes and possible phenotypes. So if the genotype is A and A, phenotype is A. If it is A and O, it is also A because of homozygous dominant, heterozygous dominant. Then B and B, it is again B. B and O, it is again B. If it is AB, because of codominance, you have blood group AB. And if it is O and O, you will have blood group as O. So just discuss these genotypes and phenotype. So this is the genotype, then discuss the phenotype, and for each blood group, what are the different antigens that are present, and then also discuss the dominant recessive relationship among them, and finally talk about the ABO compatibility. That is, AB is universal recipient, whereas O is universal donor. So somebody with O can donate to all of the three. Somebody with AB can receive blood from all the other three. So talk about the ABO compatibility. And finally, if you have the space, you can also talk about the distribution of different alleles in the population. So if you look at any individual, this is the percentage of variation of this. So allele A, O is found in maximum. O is found among 60% of the individuals. A is found among something like 25, B among 10, AB is among 5, and this is 60. So it all adds up to 100. So you can also discuss the relative distribution of each of the alleles in various sections of the population. That's how you can understand ABO blood groups. Very simple. The basis of blood groups itself, that is based on the presence of different cell surface proteins, and then discuss the dominant recessive relationship between AB and O, and also discuss about the relationship, which antigen means which blood group, and then finally genotype, phenotype, and then compatibility, who can donate blood to whom, and lastly distribution of different alleles in the population. That is the framework for ABO blood groups. Next question is the question from Applications of Anthropology. This question is eugenics. The question from Applications of Anthropology, and it is eugenics. So what do we can begin by defining what you mean by eugenics. So what is eugenics? Eugenics is first define it. What is it? It is artificially improving human species nothing but artificially improving human species by the manipulation of inherited traits. Artificially improving human species by the manipulation of inherited traits. This is what we mean by eugenics. And eugenics can be traced to Plato, and in the name of eugenics, many crimes have been committed against humanity, like by the Nazis in the form of Holocaust and so on. So first define it, and then talk about first definition, then types. We have different types of eugenics. For example, something is called, one set of eugenics is positive eugenics. Second type is negative eugenics. What is the difference? Positive eugenics means to increase the frequency of desirable alleles. Positive eugenics is to increase the frequency of desirable alleles. What is negative frequency? Negative eugenics is to reduce frequency of so-called deleterious alleles. That is the difference. So one is trying to increase the frequency of desirable alleles, another is trying to reduce the frequency of alleles. Then discuss the means. What are the different means by which we can do this? What are the different means by which we can do eugenics? One is called assortative mating. One is assortative mating. This means trying to favor. So, for example, tall people mate with tall people. So, you choose those who are like you, or favoring some traits over others in case of mating. This is harmless. So, favor some traits over others. That is assortative mating. Second is cloning. Second kind of eugenics is cloning, where you clone an entire organism. Third is through gene therapy. Third is by the issue of gene therapy. And then discuss the problems. Discuss the various problems that can arise because of eugenics. What are the different problems? First is called dysgenic effect. So what's happening in dysgenic effect? We are suppressing disease phenotypically. So we are trying to suppress the disease phenotypically. So defective genes continue to be propagated. So that is dysgenic effect. Second is, this reduces variation, because you are now removing some genes, because by calling them defective, you are reducing the variation in the gene pool. And third is, of course, the feelings of racism and elitism. Racism and elitism. And in the name of all this, we are trying to spread discrimination through eugenics. And as examples of this, you can give eugenic policies of the Nazi Germany. So that is how eugenics is a problematic process. So talk about the definition, discuss the definition, discuss the types, positive, negative, means of doing it, that is assortative mating, cloning, gene therapy, and then the different problems that can be associated with eugenics, that is dysgenic effect, reducing variation, and then discrimination and elitism. Next concept is fertility and fecundity. This is very easy, so we don't have to go into great detail. First, define fertility. Define fertility. Fertility is the actual, define fertility as well as fecundity. Fecundity refers to the biological, this is biological capacity to reproduce. Fecundity is the biological capacity to reproduce. Fertility is the actual reproductive performance. This is the actual, one is the actual reproductive performance, the other is the biological capacity to reproduce. So fecundity means biological capacity to reproduce, fertility is the actual reproductive capacity. And then discuss cases. Somebody can be you cannot have fertility without fecundity. Fecundity is necessary for fertility. Fecundity is necessary for fertility. But there can be cases where you can have fecundity, but you can still end up being infertile. That is, if you have the biological capacity, but if you opt not to have children, or you opt out, you practice celibacy and don't have sexual relations, then what happens is that fecundity does not translate to fertility. So fecundity is a necessary condition, but not sufficient condition for fertility. And then discuss the various factors. Discuss the various factors for both fertility as well as fecundity. Fertility factors and fecundity factors. Here you have 11 factors given by Kingsley Davis and Judith Blake. They gave around 11 factors. So you can discuss these factors in your answer, and that's it. And finally, significance. Fertility and fecundity are very important in the sense that these two play a very important role in determining the population size and population growth as well as population structure. Then 2b, blue zones. What do we mean by blue zones? Blue zones are places, regions in the world where people are living longer. These are areas or zones in the world where people are said to be having longer lifespan. So the number of people who are living more than 90, or the number of people living over greater than 100 years is very high in these areas. So blue zones are parts of Earth or regions on Earth where some people are said to enjoy a very, very long lifespan. That is what we mean by blue zones. So they are lived longer than average, and we have detected 5 blue zones. Generally, when we say blue zone, we have 5 of them in mind, and the most important of these are Okinawa, Sardinia. These two are very, very famous for their lifespan. In fact, the lifestyle of this Okinawa has become the subject of a book called Ikigai. Then you have other places, like in Costa Rica there is something called as the Nicoya Peninsula. Then we also have another place called Icaria in Greece, and another place called Loma Linda in California. In California there is Loma Linda, then Okinawa, Sardinia, Loma Linda, and Nicoya and Icaria. So these are considered to be blue zones. So define them, list out the blue zones, and then what are the supposed factors? What are the factors that play a very important role? What are the factors common to all of these which promote a very healthy lifestyle? So if you look at this here, you see some common factors. So all these societies give high importance to family, no smoking, they have a very plant heavy diet, physical activity, engagement with the community like being part of the church or being part of the local self-help group. They eat a lot of legumes. These are some of the habits that are common to all of them. So we can say it is probably these conditions, these environmental conditions which are contributing to long life than probably any genetic inclination or genetic potential. And then we can discuss criticism. There is also some criticism against this concept of blue zones. The criticism is, one of the criticism is that these are largely not based on any scientific proof. They claim that this is not based on scientific proof, or it is not thoroughly investigated. It is just based on impression. People believe that blue zones are good, and that's why blue zones exist, and there is no scientific backing to blue zone diet or blue zone habits. Then the other things are that the so-called longevity in blue zone itself is a myth. So some others claim that that more recent studies show that it is not really true that people here are living a very long lifespan and so on. So they claim that people here, when recently people have studied them, the number of people living into 100 or late 90s is actually not so high. So these are two criticisms or two objections against this so-called blue zone concept. Next question is about demographic transition. So this is a very important theory to explain the size and structure of population. So you can begin your intro by saying that this is a very important theory that explains how population growth happens, and this theory is generally attributed to Notstein. Notstein is a person to whom this theory is attributed. So what do they believe? What do these theories propose? They propose that there are three stages in which the population grows. In stage 1, you have low birth rate and you also have low death rate. In stage 2, what happens is that, in stage 1, you have high birth rate and you also have high death rate. So both death rate and birth rate are high in stage 1. In stage 2, because of better economic conditions, because of improvements in healthcare, improvements in nutrition and lifestyle, what happens in stage 2 is that death rate gets controlled, whereas birth rate still remains high. So the birth rate is high, whereas death rate has increased. So this results in death rate has reduced. So because of this, the population explosion. This results in what is called as population explosion. Then in stage 3, people also control their birth rate. They reduce the birth rate through contraceptives and other practices. So you have low birth rate and low death rate. By this time, population now stabilizes. By this time, population begins to stabilize. And you can show this in a diagram. So in stage 1, it is like this. Then this is stage 2. So this is stage 3. So this is in stage 1, first death rate declines. So this is death rate. This is birth rate. This is stage 1, stage 2 and stage 3. And then show also how the overall population is growing. Here population is more or less stable, and then here it reaches a level and stabilizes. So this is population size. So this is how population size can be understood. So population size is initially at a low level, then in stage 2 there is explosion, and in stage 3 population begins to stabilize. So this is demographic transition, and of course there are a lot of criticisms to it. Discuss criticism. One criticism is that it links demography only to economic conditions. It ignores the possible role of social or political factors. In demographic transition is linking population growth and population size entirely to economic conditions. Second is that they say that it is based largely on the experience of Western countries and countries like Japan, that it is based on developed countries' experience. Third objection is that after HDI crosses something like 0.9, it says that once again the birth rate begins to rise, that people begin to have more and more children after very high levels of development. So those objections are ignored here. Next question is paternity diagnosis. This is again a question from applications of anthropology. So it's very simple. For paternity diagnosis, first we can define it. We can define it by saying that what is this? This helps to establish genetic proof. PD or paternity diagnosis helps to establish genetic proof whether a man is the biological father of an individual or not. Whether a man is the biological father of an individual or not. This is essentially what paternity diagnosis is all about. Then we can discuss the broad methods in which we can do this. There are two methods to do paternity studies. One is called exclusion method. Another is called inclusion method. What is exclusion method? Here in exclusion method we use different kinds of blood groupings. Like for example, this is based on blood group polymorphism. This is based on blood group polymorphisms like ABO, MN and RH systems. These are most widely used. So exclusion method is based on blood grouping polymorphism. So it is based on using similarity between ABO. Let's say if the father's blood, if the child's blood group is certain thing, then what could be the father's possible blood group? So, but these systems are exclusion in the sense that they help to rule out. They only help to rule out some possibilities. They won't tell you who is it. They will tell you who can possibly not be. We can know who cannot be, but we cannot know who can be. Hence it is called exclusion method. Inclusion method is telling us certainly who is the person, and DNA fingerprinting is an example of inclusion method. So this gives us accurately about 99.9% accuracy we can know who is the father. So and then you discuss DNA fingerprinting and what it is all about. Alec Jeffreys and the different steps in DNA fingerprinting can be broadly discussed here. And we discuss DNA fingerprinting in case of test 6. So just briefly capture that discussion here once again. And that's how we can close this answer. Then the next question is about growth and development. The next question is about growth and development. First, begin by defining what is growth, what is development. So here we have defined what is growth and what is development. Growth is, as we discuss in classes also, growth is quantitative, whereas development is qualitative. So it refers to increase in physical dimensions of an individual, like increase in height, weight, or various parts and organs. This increase is again limited by hereditary factors. And then development. Development refers to enhancement in the functioning. So development refers to qualitative or improvement in the functioning. It is about functional specialization. It is about functional specialization, whereas growth is generally discussed in quantitative terms. And development is evaluated by improvement in the performance of the human body. Development is always gradual, progressive, and diversified. We can also say that growth begins with birth and continues almost till death. So development, on the other hand, is about functional specialization, and it has a certain closing point. Discuss this and then talk about different possibilities. Talk about different possibilities. Let's say there is growth, but no development. What happens? This is when you have people with mental retardation, autism, and so on, where their body looks normal, but they don't have cognitive abilities. That is called as growth with no development. Then we can also have no growth but development. This you see among dwarfs, in case of dwarfism, or in case of certain people who are called as midgets. Among them, we see that there is growth, but we also see that there is no growth. The body is very short, but they they look very normal. They have normal cognitive functions. They also have normal reproductive functions. This is an example of having development without so-called growth. So discuss these two and then draw these growth curves. Growth curves which show the growth patterns in different organs of the body. So this is how reproductive organs grow. Very slow in the initial phase and then pick up after puberty. General body grows like this, fast in the early periods and then has a slower pace and then picks up pace again after adolescence. And then brain and head grow very fast in the early period and then they again begin to plateau. And then this is how lymphoid system grows. That is, lymphoid system grows, reaches almost double its capacity by around puberty and then stabilizes. So draw these growth curves. And you can also discuss another concept called as the secular trend in growth, which shows that increasingly year after year, what we are seeing is that the overall height of individuals, both girls and boys, is increasing. This is called as secular trend in growth and development. Discuss them and then you can briefly touch upon growth factors. If you have the time and space, you can talk about different factors of growth like genetic factors, environmental factors, biochemical factors and socio-economic factors. So that is how you can write answer for growth and development. Next, third question. This is about aging. Here, the question is referring to two systems of aging. One is called biological aging, the other is called chronological aging. So, the question is asking for two kinds of aging, biological and chronological age. In fact, I missed this, I'm sorry. In fact, when you are discussing this concept of blue zones, so there itself you can write this. In blue zones, in answer to blue zones, you should definitely include this biological and chronological aging concept. You should say that blue zones are places where people generally tend to have lesser chronological age for the given biological age. So what is blue zone? These are zones where people are young, which means these are zones where the chronological age, compared to the chronological age, the biological age is less. So people look young and healthy. That is what we mean by blue zone concept. So you can talk about this biological chronological aging concept even while talking about blue zones also. Now, when it comes to this, first talk about what is biological age. Biological age means, first discuss chronological age. Chronological age simply means age in numbers. It simply means age in numbers. Biological age, on the other hand, is age at cellular level. This is age at cellular level. So these are two different things. And how do you measure biological age? You have certain things called as biomarkers of age. Using these biomarkers of age, we calculate the biological age. So what can be these biomarkers of age? This can include things like skin elasticity, and basal metabolic rate, lean body mass. To what extent do we still have lean body mass, and other things like skin folds, graying of hair. All of these are measures through which we calculate a person's biological age. And then talk about, again here also you can talk about longevity hotspots or so-called blue zones. Longevity hotspots are places where biological age is less than chronological age. And give examples of again Sardinia, Okinawa, Loma Linda and other places. Then reverse also is possible, where the biological age is much more than chronological age. This can be seen in case of certain diseases like progeria. Here people look much older than what they actually are. Or it can also happen when people don't take good care of their health, or when people have poor lifestyles, poor diet, absence of physical activity and so on. In such cases again, the biological age can look much more than so-called chronological age. That is the discussion on this. And then we have to discuss the theories of aging. So then we have to go to theories of aging. So theories of aging broadly can be classified into two types. Some are called programmed theories. Programmed theories, these are theories which believe that the aging is programmed into the human body. These are theories which propose that aging is programmed, in the sense that there is some kind of a clock in the body, some kind of code is present in the body which which decides how aging happens. And in this approach we have four theories. One is called programmed senescence theory. This believes that there are senescence or old age is programmed into our genes itself. Then there is telomeric theory. Telomeric theory is telling us that if you take our DNA, which has a double helix structure, it suggests that at the end of every DNA you have something called as telomeres, and they say that these telomeres become shorter and shorter with cell division and with age. As age passes, telomeres length decreases. Their length decreases as we age, and because of this decreasing length of telomeres, people tend to age. That is the position taken by telomeric theory. Then we also have another theory called immunologic theory. Immunologic theory believes that aging happens because of decline in the functioning of immune system. Endocrine theory believes that aging happens because of endocrine system or hormonal system. They believe that hormonal system contributes to aging phenomena. Then another theory, other theories are called error theories. Error theories are saying that there is no clock or anything. Aging happens because of errors, or aging happens because of mistakes in certain places in the body. Where can these mistakes happen? One, they say that aging is because of body's wear and tear. Body is getting worn out with increasing time. Second approach is that they say free radicals. Free radical theory is telling us that as we live, we begin to produce more and more free radicals. We begin to produce more and more free radicals, and these free radicals are highly reactive. Because they are highly reactive, they go and interact with other cell lining, cell walls and damage them, and this damage eventually piles up, leading to aging. Then protein synthesis. This theory, the third theory, is telling us that aging is because of some errors, and these errors happen in the protein synthesis process. Then you have cross-linking theory, which says that aging is because of cross-linked proteins. Somatic mutation theory tells us aging happens because of large-scale mutations called as somatic mutations. They contribute to aging. And then histone theory tells us that aging is because of the decreasing binding capacity of histones. There are histone proteins which bring the DNA together, and these proteins begin to weaken. The strength with which they are binding the DNA fragments begins to weaken, and because of that aging happens. That is the position of histone theory. So these are the major theories for aging. Next, 3B. This is about forensic anthropology. This is about forensic anthropology. For forensic anthropology, things are very simple. This is a very standard question. It has been asked quite a few times. We can expect this question to be asked this year also. So please prepare this seriously. So what is forensic anthropology? First, define it. This is use of anthropometric knowledge. Forensic anthropology is nothing but use of anthropometric knowledge for the purpose of study of crime. to study crime and other things. That is what we mean by forensic anthropology. And how do we do this? We achieve this by various steps. What are the different steps in forensic anthropology? First, what does forensic anthropology use? It uses for its study, it uses things like bone fragments, or tissue remains, blood samples, saliva, semen, hair. So these kind of things are collected, and they do their analysis based on this kind of data. So what is the forensic anthropologist method? So when it finds this evidence, first thing is to do is whether the bones are human or non-human. First we have to verify this. Once this is done, we have to see whether there is one or many individuals, whether you have one or many individuals involved here. The bones that you found belong to one person, or do they belong to many persons? So one or many individuals. Second, once you verify one or many, then you have to go about a particular process. First you have to identify sex, then you have to identify age, then we have to identify, if possible, race, then height, etc. So this is the logical step. How do you identify sex? To identify sex, we generally use two bones. One is skull or cranium, another is pelvis. These two bones can be used to identify whether these remains, the bone fragments, belong to male or female. So if you look at this diagram, there are the differences. So female skull looks somewhat like this, whereas male skull looks somewhat like this. So there are clear differences. In case of male, the forehead is less rounded, the supraorbital ridges are larger, the zygomatic arch is heavier, you generally have heavier teeth, and the orbits are also square. And in case of pelvis, what you notice is that, so this is also a clear difference between male and female cranium. So this table also gives you very clearly how the male and female cranium can be varying from one another. So that is male, this is male cranium, and then you have female cranium. Then here you also have pelvis. In pelvis also we find some differences. These differences are found in different areas. For example, in case of male, they have more robust muscle attachments, and the overall appearance also tends to be massive. In case of females, the muscle attachments are less robust and they have very less massive appearance. Then here, subpubic angle is wide, here it is narrow. So if you just look at the figure, what you will see is that this looks, male pelvis has a more triangular shape. Female pelvis, on the other hand, has a more rectangular shape. This has a more of a rectangular shape, and this is what we mean by pubic angle. So here the pubic angle is wide, there the pubic angle is less wide, and here the bones, the pubic ramus is thinner, here it is thicker, and sacrum is wide and straight here, sacrum is narrow and more curved here. So these are some of the differences that you will find within pelvis for male pelvis and in case of female pelvis. So this is how we can identify sex. Age. How do you identify age? Age you can identify based on teeth, which teeth erupt at which age. You can also identify based on damage to bones, or sorry, not damage, based on bone growth. Age can also be identified. So using teeth and bone growth, we can identify age up till like 18 or 20. But after 20, it becomes very difficult to identify age. And you can again identify age in case of old age. So because people who are old tend to show certain markers, like if they have bones which are worn out, then it leads to osteoporosis. or if they have knees which are worn out, that again is an indicator of age. So we can find old age indicators also in this, in some bones. So bones, using bones, age can be estimated in general up to, let's say, 20 years. And once again, you can identify old age markers, but in between it is very difficult to exactly estimate age. After that, we can see whether there are any racial markers. If you have certain racial features like having epicanthic fold, then it means mongoloid and so on. And then you estimate height. How do you estimate height? For estimation of height, you take some indicator bones. Generally, we choose femur. So if you have a femur or thigh bone, if you have, based on the length of you have tables which tell you this is the length of the femur, this could be the height of the person. So based on the femur length, we can estimate the height of the person. And once this is done, after this, then finally we can go for facial reconstruction using facial reconstruction. This can be done using portrait drawings, or it can also be done using 3D clay modeling or 3D printing these days. So all this can be used to build this analysis or do this kind of work. So clear? This is how we can understand forensic anthropology. Age, sex, race, height, then facial reconstruction, and then the first few steps. And you can give any case studies. Any case studies of some forensic studies which helped identify people. So one such famous case study is the Kennewick man case study, that where forensic anthropological knowledge was used to identify some very old person in the Latin America. Then 3C, discuss the role of disease in human evolution. Discuss the role of disease in human evolution. This is again a question from epidemiological anthropology. I have shared this handout on the Telegram group of the test series. There, complete discussion and detail of this is given because many students lack content for epidemiology. I thought we can use this handout to draw our content for epidemiological anthropology. So if you look at this, we'll see that one of the things that epidemiological anthropology does is that it studies how at different stages of human culture we may have had different kinds of diseases. That is one of the focus of epidemiological anthropology. So in epidemiological anthropology, if you look at this handout, I'll give a broad summary. You can get more details from here. So what we are saying is that in different kind of societies we have different kind of diseases. So when people were foragers or hunting gatherers, we begin to see in this stage people are more vulnerable to zoonotic diseases. Here people are more vulnerable to zoonotic diseases when they are living in the stage of hunting gatherers. So what are these zoonotic diseases? Zoonotic diseases can be many things. This can be things like brain disorder, like encephalitis, because people are hunting animals and are dependent on wildlife. They are also subjected to zoonotic diseases. Even COVID, for example, is a zoonotic disease. COVID-19 is a zoonotic disease. So you can have brain disorders like encephalitis, or you can also have intestinal diseases like trichinosis. Along with this, other diseases like tetanus, rabies, sleeping sickness, all of these are have increased in number due to hunting gathering way of life and other things like some parasitic diseases. Along with this, some parasitic diseases like lice and intestinal worms. These also were prevalent in the hunting gathering stage. But one interesting aspect of hunter gatherers is that in hunting gathering societies, epidemics or pandemics are less. Epidemics or pandemics are very, very less in hunting gathering societies because uh, first they live in such small groups of small population groups. So a disease by the time, and they live in scattered areas. So it is very difficult for disease to jump from one group or one band to another band because they are living away. And by the time two bands meet, the people with the disease could have recovered also. So the virus is not able to spread further. So that is why epidemics are very, very rare. And then discuss, once we shifted to agriculture, what happens? We went through something called as epidemiological transition. We went through some kind of epidemiological transition, and because of this epidemiological transition, on the one hand, infectious diseases initially increased because when you are living in agricultural kind of life, what happens is that you are living in large numbers. So in villages where sanitary conditions are less, you have domesticated animals, you are now breeding, you are now having fields which are irrigated where water is held stagnant. Because of all this, parasites like vectors like mosquitoes breed, which increases the prevalence of malaria and other vector-borne diseases. All of these infectious diseases increase in agricultural societies. But as societies progress, slowly infectious diseases decrease and they are replaced slowly by cardiovascular diseases and lifestyle diseases or chronic diseases. Chronic diseases increasingly begin to replace infectious diseases. So cancer, CVDs, for example, as societies become more and more surplus economies, then these kind of diseases increase in number over the traditional infectious diseases. And then slowly, when you go to industrial societies, and one of the reasons for the prevalence of CVDs, lifestyles and all of this is diet. Because our diet, we evolved, all of us evolved as Paleolithic hunter-gatherers, but with agriculture, our Paleolithic diet is replaced by more cereals and more carbohydrate intensive foods. As a result of this diet imbalances, we experience more and more CVDs and lifestyle diseases. That we can write. And then as we move to industrial age, then we experience more and more of what is called as zymotics. We experience more and more of what is called as zymotics. These are infections which spread from person to person in crowded areas, because in industrial age we are all living in urban areas and high population density areas, as a result of which we begin to experience something called as zymotics. So that is how you can understand role of disease in human evolution. I shared the complete handout. You can go through it for more reference. 4a, somatotyping. This is very easy. What is somatotyping? There are two methods, Sheldon, Heath Carter, to discuss each of them. So first, somatotyping is nothing but it is a morphological classification of people. morphological classification of people. Then there are these two systems. First you have Sheldon system, which divides people into three categories: ectomorphy, endomorphy, meso. I shared a complete handout on somatotypes on the group. Please go through that. If you go through that handout, you will come across what is endomorphy. Endomorphy is to have generally fatty appearance. Ectomorphy is to have a general lean body or thin appearance. Mesomorphy is to have a very lean or muscular appearance, and you have features for each of this. In Sheldon's method, we give a person rating, a three-dimensional rating based on each of these indicators. So talk about that, and then discuss the limitations of Sheldon's method. One, Sheldon's method is primarily anthroposcopic, and it is based on Western limited sample of white students, white males. That's why you have Heath-Carter method. Heath-Carter method takes this template, but is more scientific in the sense that Heath and Carter have not done anthroposcopic, but they have gone for anthropometric measurements. Discuss that and talk about the unique ideas of Heath and Carter. You'll get all these points in the handout I shared on the group. And then discuss the applications of somatotypes. What are the applications? They are used in sports, they are used in industrial design, they are used to manufacture things like industrial production of garments, shoes and other equipment. That's it. Then we have the different growth methods. This is also again easy. When we talk about growth methods, we primarily have three types of growth methods. That is longitudinal method, cross-sectional method and sequential method. Longitudinal method is, so you can draw a diagram which shows it. So in longitudinal method, this is cross-sectional method. This is magnitude of what you are measuring. So in longitudinal method, what we do is we take some people and then we measure them regularly over a long span of 15 years or so, and based on them we calculate growth data. In cross-sectional method, what do is we take people at a given point of time and we compute, like today we take people of different ages, 3, 5, 7, 8, 13, 15 and so on, and calculate heights of them, and based on that plot curve. Then what is sequential method? It is a mix of both. In sequential method, you take people of a limited age range, that is 5 to 10 years, and then you travel with them for over 5 years and you collect the data. So that is how you can explain each of them. Very simple. And then discuss the merits and demerits of each of them, and conclude that, in conclusion, you must write, no method is perfect. We have to choose a method based on the growth, the objective. We have to choose the method based on what growth parameter we want to study and measure. Next is nutritional anthropology. So what do we mean by nutritional anthropology, and how do we use it? So nutritional anthropology is to assess if there are any deviations from, nutritional anthropology is used to assess if there are any deviations from normal growth and development process. To assess this, we use nutritional anthropology. It defines the nutritional status of a person and based on our existing knowledge of what is normal growth and normal development. And for this, generally, they use 4 indicators to measure this, what is normal growth. One is called weight for age index, and if somebody is not normal, here in this we call them as underweight. Second, we have this is called stunting. third weight for height, and this is called wasting. We have these three. In addition to this, we also use mid-arm circumference. We also use mid-arm circumference as a measure of thinness. And all these three are used for young people. For adults, we use BMI. BMI is equal to weight by height squared. That's it. And BMI alone is not sufficient, because BMI does not tell us if somebody is fat or somebody is overweight. It does not tell us why that person is fat or overweight. So to get those things, we use something called as waist to hip ratio, and we can also use something called as fat folds at biceps or triceps. So this is it. So defining growth using some indicators, and we also use something called as, for deviations, we have cutoff points. For deviations, we also have something called as cutoff point. This cutoff point is generally around 80%. Cutoff point is for weight for age, 80%. Cutoff point is 80% for weight for height, and cutoff point is 90% for height for age. Along with this, we also use something called as indicator population. An indicator population that we use is generally based on Western standards. So this is nutritional anthropology, and discuss applications. Applications are how it can be used to improve overall nutritional status of people. And in countries like India, where we have high hunger, high stunting, we can use the insights from nutritional anthropology to improve the reduce hunger and improve the nutritional status of children. That's it. Then we have race and racism. So very simple. First, define these things. Tell race is a biological concept that is used to classify people based on their biological characteristics. Then we have racism. Racism is a cultural concept. Racism is a cultural concept wherein some people believe they are superior over the others. So discuss both these. Discuss the ideas of Franz Boas and how race was just used to classify people, but racism is being used to discriminate them. So racism is wrong. And in general, we can say today, then discuss the criticism of race concept. How race concept is today not relevant anymore, and because of these criticisms today, instead of race, we are studying human variation not in terms of race or racial constructs, but we are studying human variation in terms of something called as clines. And then racial classification of the three different races. So the three major races are Caucasoid, Negroid, Mongoloid, and in the table that I gave here, you can find different things. So generally, when we are studying racial variation, racial characteristics, we can classify them into two types. Some are called anthroposcopic. Then we have anthropometric. Anthroposcopic skin color, hair form, fingerprints, all of this. Then we have anthropometric. Anthropometric can be things like what you measure: nasal index, facial index, cranial index. Along with all of this, you can also have certain genetic criteria. So all of that I have discussed here. Caucasoid, Negroid, Mongoloid, skin color, head hair, head form, body hair quantity, face, eye, nose, chin, lips, stature, ABO blood group, RH factor, and different things. And here I have given you how nasal index can vary. Here we also discussed face form and how facial index can vary, head form and cephalic index, how that can also vary. And finally, this is a summary of the blood group variations that you can find. Blood group is nothing but genetic criteria. Right? Then we move to the next question, 5b. Define adaptability and acclimatization. Define adaptability and acclimatization and discuss the major adaptations to heat and cold stress. This is very important because generally every year we get one question from ecological anthropology, and this year I think we can expect on heat and cold stress. So this is a very interesting diagram. This diagram shows what is acclimatization. It is short term, immediate. Adaptability is developmental. Then adaptation means this is at gene or genetic level. This is genetic. This is short term and immediate. This is based on birth. So you can draw this diagram to explain anything, any concept in adaptation and adaptability. I'll give you a framework for both heat and cold stress. How do you write answer for this? First, discuss the nature of stress. What is the stress? In case of heat, the stress is called hyperthermia. Explain what is hyperthermia and also explain what is hypothermia. Hyperthermia and explain what is hyperthermia and explain what is hypothermia. Hyperthermia means to explain what are both of these, you need to talk about humans. Humans are homeothermic animals in the sense that our body functions very well only at around 37 degrees Celsius. This is the ideal temperature for the functioning of the body. Over and above this, body may not function well. So in hyperthermia, body is facing more than 37. In hypothermia, body is facing less than 37. This is the stress. And after stress, we discuss different responses. What are the responses in terms of physiology or acclimatization? In case of heat stress, it is sweating. Here it is cold stress, means shiver. Here we experience vasodilation. That is, in heat stress, the body is trying to lose more heat. So to lose more heat, you will sweat. Blood vessels also, more blood flows to the outside of the body. Here you are trying to conserve heat. And here you are trying to lose heat and produce less heat. Here you are trying to produce more heat and conserve heat. To conserve heat, blood vessels become thinner. That is called as vasoconstriction. That is acclimatization. And then you can talk about adaptation or gene level changes. Here discuss Allen's rule, Bergman's rule, and Glauger's rule. Glauger's rule is about skin color, Allen's rule is about body extremities, Bergman's rule is about general body size. And lastly, discuss the different cultural mechanisms. So, for example, in hot, cold places, people live in things like igloo. People also chew things which eat protein-rich food, take alcohol to increase heat production and so on. and people live in structures like this. They wear layers of clothing, they sleep in boxes, they sleep underground, and they may also reduce in hot areas. People reduce outdoor activity in middle of the day, they wear light clothes, and they eat food which generates very less heat. So discuss about all these things, right? And then the last question is aging and senescence. I think the second part, theories of aging, we already discussed. Theories of aging we discussed in 3A, so we won't discuss theories of aging. I'll just quickly discuss what is aging and senescence. So define both these concepts. Aging is nothing but growing old, increase in number of years, and aging again has two dimensions to it, chronological and also biological. And aging starts with birth and continues all the way till death. That is aging. What is senescence? Senescence is a component or it is a part of aging, and it generally refers to the later stage, or senescence refers to deleterious changes that happen in the last phase of life. That is senescence. And then discuss the 4 factors or 4 features of senescence. That is, senescence is compulsory, senescence changes are deleterious, they lead to progressive decline in health, and they cannot be inescapable. That is senescence. So just define aging and then say aging is a continuous process, but senescence is, on the other hand, it's the last aspect of aging. Senescence is also called as old age, and discuss 4 features of senescence and discuss senescence related changes. What are the changes? You see different changes in skeletal system, in muscular system, general strength, body begins to graying of hair, skin losing its elasticity. All of these are senescence related changes, loss of reproductive capacity. So discuss the different changes which happen in old age, and then also finally discuss the various theories of aging. So this concludes our discussion of test 7 also, and with this both test 6 and test 7 discussions are concluded. I hope, please also go through the handouts and materials that we have discussed and that I have shared with you on the group, and take some value, whatever value addition is available in these places, right? So with this we will conclude this session, and we'll again discuss, I think the only other test remaining is the full length test, so we'll discuss full length tests once they are completed, right? So all the best, and I hope you do well in the upcoming exams as well.